All right, welcome back. In this video, I want to introduce and explain how we're going to use a method called substitution for solving integral problems in calculus. So imagine you have an integral that looks something like this. Let's say it's I is equal to the integral of 4x, and then some trig function like sine of 3x squared dx. And you're tasked with the problem to find out what is the solution, or what is the integral. So if you look at the integral table that you're provided with in your exam or the formula sheet, whatever that you work off of, and you don't see this exact form, then you might want to try substitution. And particularly if you see the integrand being the thing that's getting integrated, basically from the 4 over to this closed bracket, if it contains a trig function, this is a good candidate for substitution. And in this case, we're going to substitute what's inside the angle here, inside the brackets, with just a letter u, and we're going to kind of change the variable that we're working with, and then we're going to change it back to x afterwards. And we're going to see that that's actually going to greatly simplify the integration for a lot of problems with this form. So I'm just going to work through the problem. I'm going to show you how it works, and then talk a little bit about why it is and what we're doing. So we're always going to, with trig functions, we're going to take what's inside here, we're going to take the angle, and we're going to substitute that with a u. So we're going to have u is equal to, in this case, 3x squared. Now with these problems of substitution, what we do is we want to find the derivative of u with respect to x. So we're going to take du dx, and we're going to derive the right hand side. So we'll bring down the 2, so this is going to be 6x to the power of 1. And then we're always going to need to rearrange this to have isolate dx on one side. So basically we can just bring the dx up here and bring the 6x down, however you want to reason your way through that. But basically we have dx is going to be equal to du divided by 6x. Now what we're going to do is we're going to take u here and we're going to substitute it into this expression. So we're going to have the integral is equal to 4x sine of u dx. Okay, so this is where the substitution comes in. We're just calling this function, the one that we're substituting u, we're going to put it in here. Now we have an expression for u, but we also have an expression for dx. So let's replace what we have dx here with what we have figured out here based on our function u. So this becomes, this integral is equal to 4x sine of u, and we replace dx with du over 6x. Now what we can do is we can cancel out some things. We have an x here that conveniently cancels with that x, and the 4 over 6 ratio we can reduce to 2/3 and bring it out. So we're going to get 2/3 times the integral of sine of u du. Now this form is a really basic form of integral that if you know what it is already, you can substitute it in. The solution is negative cos of u. But if you're not sure what it is, we can look it up in our integral table, which is right here. And this is a link that's on the Engineer for Free website. I'll put the link in the description below where you can get this, but this is just a typical table that you would probably have in a Calculus 2 exam anyways, or calculus exam. But basically here, we're looking for the integral of sine of x, and we can see here, basically it's here, the integral of sine of x is equal to negative cos of x plus c. So anytime you have an integral in this form, you can immediately replace this whole thing with the solution. In this case, it's a negative cos of x plus c. So let's bring that back into our worksheet. And basically we're just going to be replacing this whole thing. We can even write it down here. So we have the integral of sine of, in this case it's u, we can write sine of x, it doesn't really matter. So sine of u du is equal to negative cos of u plus c. So we're just going to substitute, like I said, this part exactly for this part. So that's going to give us negative 2/3 times cos of u plus the arbitrary constant c. Now that is a solution based on this table entry, but this still is in terms of u, and the original problem was in terms of x. And so we want to resubstitute what we have for u here with the original function in terms of x that we have for u. So we'll just replace that with our final answer, which is going to be negative 2 over 3 cosine of 3x squared plus c. And this is the solution to the original problem that we had up here when we're looking for what is the integral of this expression. So that is how we're basically always going to solve these integrals using substitution. So when the integrand contains a trig function, we're always going to substitute u as the angle, which is basically the stuff inside the brackets. If the integrand contains an exponential, we're going to set u equal to the whole exponent. So basically e raised to the power of something. We're going to set that all equal to u. And then we're just going to take u. We're going to derive u to have du dx. We're going to figure out what that expression is. And then we're going to rearrange so we get x. And then we'll be able to just proceed with the integration and then resubstitute back in u at the end. If the integrand contains a natural logarithm, then we're just going to set u to what's inside the logarithm, basically inside those brackets as well. And if the integrand contains a power of an expression, for example, like 2x squared plus 1 all squared, then we're going to set everything that's inside those brackets again to u, and again follow these same steps. Take the derivative of u, rearrange for dx, and potentially isolate for x. In the case where we get to a step down here and we have an expression with still mixed u's and x's, like here the x is cancelled out, but that's not always the case. And if it's not the case, if you end up here and you have something like x sine u du for whatever reason, which I guess would have happened if this was for x squared, because that 1x wouldn't have cancelled. In that case, what you do is you rearrange your function for u to isolate for x. So we could isolate for x here. We would have like x is equal to u over 3 and then the square root of all that. And then you would replace that with the x that you see. And then your whole expression would then be turned into an entire function of u. And you would be able to proceed with that integral. And if for some reason you're not able to get it all into u, then you might just have a problem, and actually integration with u substitution might not be the best method, but we'll deal with that later. I think just getting started, just follow these steps. Usually replace stuff that's in brackets with a u, derive the u, isolate dx, and then sub everything back in and proceed with the problem. I think the last thing to say as well is it's just a good idea to generally choose a substitution that basically the derivative of u, so du dx, is going to be like a multiple of some part of the integral, like a different part, and you'll see that in some other problems that I'm going to work through in the next couple of videos. But that's also something to keep in mind, a target that you can shoot for, and you'll see that when we get there. But I think for now, we'll just start with a couple basic examples, work through from start to finish, and show you that it's actually pretty easy to come up with solutions to integrals using u substitution, even if the original integral looks a little bit challenging.